Using a Git repository in Visual Studio. In this video, we'll look at how to use Git with your Visual Studio project and the most common Git commands you'll perform on your repository. We'll create a repository and a branch and make some changes and commit them to the repository. We'll amend to a commit and combine commits by squashing them. Then we'll look at the staging and stash areas, what they are and how they're used. We create a remote repository in GitHub and explore pulling and pushing between your local copy of the repository to and from the remote repository. We'll look at merging branches and some more commit functionalities like cherry pick, revert, and reset. To demonstrate using Git in Visual Studio, we'll use a simple console app. We'll start with creating a local repository on your hard drive. This is also useful for a single developer that needs version control as they're developing but don't need to share it with other team members. You will always work on a local copy of a repository, even if you do have a remote repository. Once your project is created, go to the Git menu on top and select Create Git Repository. A dialog will pop up where you can select a remote repository like GitHub, an existing remote repository, or for now, just local only. Notice on the right part, it will create the repository inside your project folder. There's also an option to create a README Markdown file if you want to create some documentation for your project. When you click Create, you'll receive a notification on the bottom left, and new Git files will be added to your project folder. On the bottom right, you'll see a little dot with the number 2 next to it. This means that there have already been 2 changes initially committed to your repository. If you expand this, you can select View All Commits. This displays our repository branches. To start with, you have one main branch called Master. As you develop new features in your app, you'll add new branches for each new feature, and you can happily work on the new feature without affecting the original master copy of your app. In the master branch, we can see the 2 changes that were committed to this branch. It lists the commits chronologically descending, so the latest commit will be at the top. Here we see it first added all the Git stuff and then added your project files. At the bottom right, you can quickly see and change the current branch you are working in. We're going to create our first feature or development on our app. So let's create a new branch. From the Git menu, select New Branch. In the pop-up dialog, add a meaningful name for your branch that gives some indication what the branch is about. Notice it gives us a warning that it didn't like the space in our branch name, so it automatically added a hyphen. In the Based On field, it wants to know from which branch you are working from. Since we only have the master branch, we'll work from that. This means you'll work on a sort of copy of the master branch. Behind the scenes, Git doesn't really make a copy of the master branch. It will only save the changes you make into your new branch. The Checkout Branch option will open and place you in the branch. Once created, you'll see your new branch in the branch history window, and at the bottom right, you can see that you are now in your new Add Greeting branch. If you expand this, you can jump to another branch or even add a new branch here. We make changes to the program CS file in our Add Greeting branch. The blue bars indicate what we've changed compared to the original master. You can either double-click the blue bars or press Alt and F8. This will open a window that shows you the differences compared to the original. On the left, we see the original, and on the right, we see the changes we've made. Down at the bottom right, next to the pencil icon, we can see that one change was made. You can either click on the pencil icon or the Git Changes tab if you've set it up from the View menu. In the Git Changes, we can see that the program CS file was modified as indicated by the M next to it. There's also a back arrow to undo all your changes and a plus sign to add the change to the staging area. We'll discuss the staging area in a bit. If you double-click the file that was changed, the Differences window will open again for you to inspect the alterations. For now, we're going to skip the staging area and commit the changes directly. You have to add a commit description. On a side note, If you like, the little pencil in the commit description box will let AI generate a description for you based on the code changes. When you click Commit All, the commit is created and the change is removed from the list. Now at the bottom, you'll see that there was a total of 3 commits so far, including your latest commit, and there's 0 changes left to commit. Looking at our branch history, we can see the commit under the Add Greeting branch, shown in blue, and by whom and when it was committed. Remember, you can view the branch history either by selecting it from the top Git menu or through the little dot icon on the bottom right. Now, suppose you forget to add a small change, but you've already committed. This happens to all of us. Here we added a line of code to the greeting message. The change will appear in your change list, but instead of doing separate commit, you can do a quick amend by ticking the amend box. It will show the description of the commit you're going to amend to. Then click the Commit All button. In the branch history, you'll notice that there's no new commit, but in the Differences window, you can see the additional line of code you added. Here's a different scenario. Suppose you already have several commits, but you feel they should belong to a single commit and not clutter your branch history. You can combine selected commits into a single commit. Here, you'll need to use your own discretion and common sense. If you think you won't need to ever reverse changes from a specific commit, you can combine it with the others. When you combine the commits, all the changes will now be in a single commit, and you won't be able to reverse individual changes. Here, for simplicity, we just added another line to our greeting. The change appears in our changes list, and we create an extend greeting message commit. The new commit shows up in our branch history. Now we feel this new extend greetings message commit is really just part of the original add greeting commit, and we want to combine them into one and clean up our commit history a bit. To do this, select the commits that you want to combine. Right-click on them and select Squash Commits. A dialog will pop up, and you can enter a description for your new combined commit. After combining, the extra commits are removed, and you'll only see the combined commit in your history. Right, let's talk about staging. What is it and why we use it? Generally, staging is used when your new changes are ready to be reviewed by other team members. To add a change to the staging area, click the plus sign next to the change you want to move to staging. This way, your team members can see what changes you want to review before committing them. Here's the other function of staging. We've added a greetings class to our project. This will be used to select a greeting message we want to display. But for now, we only want to commit the greeting class, not the modification to the program CS file. So we can move only the greeting class to the staging area and commit only what is in the staging area. With the greeting class in the staging area, we can click on the minus sign to move it back to the changes list if we're not completely happy with it yet. Also notice that the commit button has now changed to commit staged, meaning only that which is in the staging area will be committed. Like with the normal commit, we added a description for the commit staged, and only the staged items are committed to our branch. There's one more area you can move your changes to, the stash area. As the name implies, if you have changes you want to commit at a later time, you can stash the changes. On the Commit All Buttons drop-down options, you can choose to stash everything or stash everything, but keep what is in the staging area. Once you stash a change, the changes are removed from your code, and it is now in the stash area. If you right-click on the stashed item, you can apply the changes again. Here you can choose to simply move it back to the unstaged area or directly move it to the staged area. There's also the Drop All and Pop All options. With Drop All, the stashed items are deleted. With Pop All, the changes are applied back and the stashed item is removed. There's something to note about the Pop option. If there's already changes to the item in the Changes area, you will first need to commit those changes before you can pop and apply the stashed changes. Now that we have some understanding of working with our local repository, let's see how we engage with a remote copy of the repository. While you will always be working on your local copy of the repository, the remote copy will give others on your team access to your changes. In many cases, when working for a company, for example, you'll probably clone an existing remote repository to create your own local copy of it. In our case, we need to create the remote repository. From the Git menu, select Push to Git Service. We're going to create our remote repository on GitHub, so we've already set up our GitHub account. It will create the new remote repository from our local repository, and you can select a license type if you want, like MIT or GNU, for example. Also, generally, you want to create a README Markdown file to provide some information for others who are going to use the repository. The remote repository name can be the same as your project name. Then for visibility, you can select private, public, or internal. Private means only the GitHub account owner can access the Git repository. Public means anybody have access to it. And internal means only your team members of your organization have access to it. If all information is correct, a Git repository with your project name is created on GitHub. Here we see the copy of our local repository that was created in GitHub with the added README file. Working with a remote repository is quite simple. You will always do work on your local copy of the repository. All you need to do is pull any changes made from other team members down into your local repository and push any change you make back up to the remote repository so others can pull it to their local copies. Right now, in our branch history, we can see there are no incoming or outgoing changes. You can see the same thing at the top of the Git Changes window. At the top right, you can see a bunch of arrows. The first dotted arrow is the fetch. This is for previewing how many changes there has been on the remote repository since your last pull. The second down arrow will actually pull the changes and apply them to your local repository. Then the up arrow will push any changes you've made up to the GitHub repository. It's always good practice to first pull changes for you to examine before pushing your own changes. However, if you're pretty confident that any changes you or your team members are making are not affecting each other's work, you can use the last sync button. This will do a pull and push in one go. For a quick demonstration, we've made some changes to the README file on GitHub in the remote repository, and we've made some changes to the program CS file on our local repository, but we haven't committed yet. Now, when we do a fetch, it will show there's one change in the GitHub repository we need to pull. When we do the actual pull, the changes are applied to our local copy of the repository. Next, we commit our changes on our program CS file, and it now shows there's one outgoing change that needs to be pushed to the GitHub repository. We click the push button, and it gives us a message that all outgoing changes were successfully pushed. Now there's 0 incoming and outgoing changes, and our local and remote repositories are in sync. As mentioned before, if you're confident about the changes, you can simply use the sync button to pull and push all changes in one go. Let's get back to our branches. Just like you can combine commits by squashing them, you can also merge branches. Here we have 2 branches, Feature A and Feature B. Feature A is based on the master branch, then Feature B was added based on Feature A. All changes have been committed and conflicts have been resolved. These 2 features are ready to go, and we can merge them into the master so that any future branches based on the master will include these 2 features. You can do that, but a good practice is to first merge the 2 features into a single branch to resolve any conflicts. From the Git menu, select New Branch. We give it some meaningful name, and we'll base it on the master branch from which feature A and B comes from. Select the checkout option so we can work with the new branch. When you're going to merge other branches into a branch, the branch you're merging into, in other words, the branch your change should be checked out. We right-click feature A and select Merge into our new branch. You can select to automatically commit the changes after merge, and there were no conflicts. Do the same with feature B. Right-click it and select Merge into feature AB. Notice that currently feature AB sits next to feature A because we already merged feature A into it. After merging feature AB now sits next to feature B. With feature AB still the current branch we're working on, go to View Branch History from the Git menu. Here we see that feature AB contains all the commits of feature A and feature B. Now, if you like, you can delete feature A and B. In the Branch Manager, right-click feature B and select Delete. Do the same with feature A. Now only your merged feature AB remains with the commits of feature A and B. What if you want to duplicate the commit of one branch in another branch? In this example, we have two branches. Feature B branch is based off the master branch and have one commit. When clicking on feature A, we see that it too is based off the master branch and have one commit. So suppose we want to apply the welcome to Git message commit in feature A to the feature B branch. First, make sure that feature B is checked out and you are working on the feature B branch. This is the branch you're going to change. Then, click on feature A in the branch list on the left and right-click the commit on feature A that you want to add to feature B. From the pop-up, select Cherry Pick. Now selecting feature B in the branch list, we see that the welcome to Git message from feature A was duplicated in feature B. What if you want to remove an existing commit? It's not as simple as just deleting it. Git needs to go through the sequence of commits to see how removing a commit affects other commits, and if any conflicts occur, they have to be resolved. One way to do this is to revert a commit. This will remove any changes made by a commit. Right-click a commit in your current branch and select Revert. A confirmation pop-up will appear. Once reverted, a new Revert commit is added to the branch. If you double-click on this commit, the difference window will show you what changes were removed. What is important here is that the commit was not simply removed, but it added a Revert commit. This way, your history is preserved and other members on your team can see the reversion. We can also remove a commit and any history of it by resetting the last commit. Right-click on the commits in your current branch and select Reset. It doesn't matter which commit you right-click on, the latest or topmost commit will be reset first. Here you have two options: either keep the changes in the staging area or delete all changes and remove the commit. We choose to delete the changes and a confirmation dialog pops up. When we confirm, the last commit and its changes are removed from the branch history. Thank you for watching our video. For more tutorials on C#, hit subscribe and click the reminder. Give us a like so the video can be visible to more people.